Good afternoon, everyone. A very warm welcome to today's webinar on the AD Advantage, Smarter, Faster, Sustainable Problem Solving. We are delighted to have you all with us today. I'm Santoshi and I'll be the host for today's session. Before we begin, a few housekeeping updates. All participants' microphones are muted and cameras turned off to maintain proper bandwidth. If you have any questions or clarifications, please feel free to post them in the chat box. We will also have a dedicated Q&A session at the end where we will address your questions. Thanks for your understanding and now let's get started. AD is all about clearly defining the problem, identifying the true root cause and taking structured corrective action to ensure sustainable solution. When the cause is addressed correctly, solution becomes smarter, resolution becomes faster and results become long lasting. That's where effective AD problem solving is designed to achieve. Since 1993, Aegis has been at the forefront of delivering cutting-edge engineering and digital solutions to manufacturing industries across India and beyond. Over the past 3 decades, Aegis has partnered with organizations across diverse sectors, helping them solve complex engineering and quality challenges. What set Aegis apart is not just a technical expertise, but a strong blend of conventional engineering practice with lateral thinking. With decades of product development and implementation experience, the team has consistently delivered value to both large enterprises and small engineering firms. From mission critical programs to exploring new technological frontiers, Aegis continues to be a trusted partner in innovation and engineering excellence. Built on this strong foundation, LiveQC Tools has been developed by a team of experts with deep experience in implementing world class quality and structured problem solving methodologies. Our mission is simple and clear to provide best-in-class tools and technologies for a better tomorrow. LiveQC Tools is designed to be simple, easy to use, and affordable, enabling organizations to strengthen the three pillars of operational excellence, cost, time, and quality. When people talk about quality problems, the focus is often on quick fixes and immediate containment. But true and lasting improvements comes from a structured problem solving. So this brings us to the today's focus, the 80 problem solving methodology. The 80 approach is a structured and proven methodology used globally to identify the true root cause, implement effective corrective and preventive action, prevent recurrence, drive sustainable improvement. When supported by the right digital tools, 80 becomes not just a method but a competitive advantage, enabling smarter decision, faster resolution, and sustainable results. Over the next 40 minutes, we will focus on how organization can practically leverage the AD advantage using LiveQC tools to solve problems effectively and build a culture of continuous improvement. Now, it's my pleasure to hand over the session to our speaker, Mr. Vishnu Shivan, Assistant Manager of Engineering Service, who will take us through an insightful and practical session. Over to you, sir.
Thank you, Santoshi. Very good afternoon, myself, Vishnu Shivan. So I'm welcoming you to the new session of LiveQC Tools, the AD Advantage, Smarter, Faster, Sustainable Problem Solving. So this is the agenda for today's presentation. We'll go through the introduction of the structured problem solving methods through AD, and we'll understand the common gaps in traditional root cause analysis. And we'll deep dive into 8 disciplines with practical insights and some real world case studies demonstrating AD in actual action, and the importance of digital tools in effective problem solving and key takeaways, and I will be open to discussion. So before we begin talking about AD or root cause analysis, I want all of us to pause for a moment. And we know that most of the organizations today are very active. So we respond quickly, we implement actions quickly, and we close issues quickly. But activity does not always have equal effectiveness, that we know that. So if we are honest, many problems don't disappear. They simply return in a different form. And that usually happens not because people don't work hard, but because we start acting before we clearly understand what actually we are dealing with. So this session is about slowing down at the right pace. So this quote by Abraham Lincoln captures a very powerful idea. So he says he would spend most of the time sharpening the axe, not chopping the tree. So in problem solving, sharpening the axe means understanding the problem, preparing the investigation, and aligning the team. But in real life, pressure pushes us all to act immediately. So we know that. So we start chopping, inspections, actions, rework without sharpening the axe. So that is where inefficiency begins. So one more thought. So Einstein take this thought in one step further. So he emphasized that understanding the problem deserves the majority of our time. But actually what happens in organization is exactly opposite, correct? So we rush into solution because customers are waiting. Management wants closure, audits are approaching. Fortunately, solution built on a weak understanding of the problem will never be stable. So this slide reflects what most teams experience. So problems repeat because the problem description is vague, root causes are assumed, and corrective actions are rushed. So many AD reports look good on paper, correct? But they don't work in reality. So this is not a competence issue. So it is actually a discipline issue. And that discipline is exactly what AD is meant to provide. So before the session, I just want to clearly set some expectations for today. So this session is not about filling formats or satisfying audits or closing issues faster. It is about thinking clearly, defining problems correctly, and eliminating causes permanently. So if leave today with some different way of thinking about problems, so this session is successful. So ADs are often misunderstood. So it is not a form, it is not a checklist, it is not just a customer requirement. So AD is a structured way of thinking that forces us to slow down, change assumptions, and use logic instead of guessworks. So before we go further into this one I have a quick introduction. Myself, Vishnu Shivan. I'm from Engineering Services Division of Aegis Companies India Private Limited. So I work closely with organizations on structural problem solving, root cause analysis, and quality systems. And what I share today is based on real world observations. So where team struggles, where AD fails, and how it can be made effective. So good thinking needs structure. So without structure, even intelligent teams can arrive at weak conclusions. So AD provides the structure, so guiding the team step by step from understanding the problems to prevent from recurrence or from recovery. So let's now walk through each and every discipline that understand its real intent. So 8 is often treated as 8 independent steps. So in reality, it is one connected system. So if early disciplines are weak, starting from D0 or D1, D2, whatever the format that you are having, so later ones cannot compensate. So you cannot fix a poorly defined problem with a strong corrective action. So everything is connected here. So let's start with the first one, D1, that is building the right team. So this is about forming the right team. So a common mistake is assigning AD ownership to a single person. But most problems are cross-functional. They involve design, process, inspection, suppliers, operations, a lot of areas are there. So how we are going to interconnect all these people with in a single area. So if the team lacks representation, root cause will be incomplete. So the next one, that is D2, is a problem description. That is problem description. So this is one of the most critical discipline. Most problem statements describes about the symptoms, not problems. So a good problem description clearly answers what is happening, where it is happening, where it is not happening, etc. So if D2 is weak, the entire investigation moves in wrong direction. So that is D2. Then D3, it is what we can say it like interim containment or stop the impact. So D3 is about protecting the customer. So containment actions are temporary by nature. So they stop the impact, but they do not solve the problem. Inspection, segregation, rework are not solution. They are just like a safeguards. So if you see some containment becomes permanent, it means that root cause is still alive or it's active. D4, that is find the true cause or root cause analysis. So this can be called as like a heart of AD. So root cause analysis is not about finding a quick answer. It is about finding the right one. So most of the time, the common mistakes includes stopping at the first why. That is using assumptions or blaming people, etc. So a true root cause explains both why this problem occurred and why it is not occurred elsewhere. So since we are talking about RCA, let me share one classic problem solving story that from the automotive industry. So this is one of the strange problem that has been taught the world regarding the root cause analysis thinking. So this query, what we got from a customer to Ford company, the Ford Motor Company, especially this definition was defined with the Ford Pontiac cars. So Ford once received a complaint that a car is having a starting issue after the customer bought vanilla ice cream, not any other flavor, only vanilla ice cream. So at first, it sounded illogical. Even it is very funny, right? But instead of rejecting the complaint, Ford investigated. They discovered that real difference is not the ice cream. Actually, it was time. But if someone knows what is the actual issue regarding this specific incident, you can share your comments in your chats itself. So what is the actual, that is what is the technical issue related to this specific incident? You can share your thoughts there. So actually what it actually happened is, we know that in the most of the cases, vanilla is the most interesting flavor and most acceptable flavor from the people's side. So in the most of the stores, it will be placed in front of the store and all other flavors will be kept at the back side. So since the vanilla was purchased faster, giving the engine less cooling time, so he purchased it and he'll come back faster, so leading to the fuel vaporization, and it is called as vapor lock. It called as vapor lock. Because of this simple issue, they have learned a simple lesson, but it's very powerful. So in these cases, symptoms can be misleading, but process never lie. So this is why true root cause analysis focus on understanding variation, not making any assumptions. So this is a very beautiful story or beautiful incident that we can apply in any root cause analysis area. So coming to the next one, that is D5. It's an eliminate the cause or corrective actions. So corrective actions must directly address the root cause. So weak root cause lead to weak actions, such as we know that the usual formats like training or additional inspection, like that. So strong corrective actions that can change the system, like process change, error proofing, design improvement. So these are the different areas that we can address. So when the system changes, recurrence become unlikely. The next one is D6. So we have to prove the effectiveness or the verification and the validation over here. So implementing an action does not mean it is effective. So what we require is the verification and validation of the current manufacturing or the engineering environment, which demands speed, traceability, and accuracy. So customer expectations are very higher. We know that product complexity is also getting increased. So compliance requirements are very strict. So in this environment, manual problem solving systems cannot be scaled with some objective evidence. So we must ask, has the problem stopped? Is the action sustainable? Or do we have a data to prove it? So that's the main point that we have to keep in your mind. So without this closure is only an assumption. Last but not the least, the last two discipline details, D7 and D8, that is prevent and reinforce. So D7 ensures that the learning is institutionalized. So lessons that we have learned must be reflected in FMEAs, control plans, or standards. So D8 focus on recognition. So when teams are recognized for good problem solving, the behavior is reinforced and repeated. So why AT works? Why when it done correctly? So when it done correctly, AT enforces structured thinking, prevents premature solutions, and drives learning. So this is how organization mature from firefighting to prevention. So this is what it meant to be a sharpen the axe. So this is what meant by Abraham Lincoln, sharpen the axe. So up to this point, we have walked through all the 8 disciplines of AT, from team formation to recognition. What we have really discussed is how problems should be corrected. But there is an important reality we need to acknowledge. Knowing the methodology and executing it consistently are two different things. So this is where many organizations struggle, not because they lack knowledge, but because they lack execution discipline. So most of the cases, challenges in the manual AD execution, the most organization today, what is still managed through emails, spreadsheets, documents, and disconnected system. As a result, so information is scattered, ownership become unclear, and data is duplicated here. So we know that why digital tools are no longer optional. So we know that the current manufacturing and the engineering environment demands speed, traceability, and accuracy. So customer expectations are higher, but product complexity is increasing, compliance requirements stricter. So in this environment, manual problem solving systems simply cannot scale. So digital tools are no longer about convenience, but they are about control, visibility, repeatability, etc. So by now it is very clear that we have to get for an effective problem solving, which is we have to keep in mind that with the context in mind that let's move from theory to practice. So I will now take you through one of the real case scenarios, uh, case study or by step-by-step procedure using a digital platform to show how the structured problem solving actually works in real time. So by now it is very clear that effective problem solving is not just about knowing the right methodology. So its real challenge is ensuring the consistency in the execution, traceability across the activities, and learning that stays within the organization. So this is exactly where digital enablement becomes critical. So what organization needs is not multiple tools or but one integrated platform that connects issues, problem solving, corrective actions, and prevention end to end. So LiveQC Tools is designed to provide that backbone. It brings together issues, non-conformance management, structured AT problem solving, corrective and preventive actions, system level updates like FMEA controls, control plans. So all within a single connected environment. So as we walk through the case study, next I will show in LiveQC Tools supports each and every step of AD, not by replacing or replacing, but ensuring the disciplined execution and the complete traceability. So we can move into the case study. Now let's apply everything we have discussed so far in the real world automotive manufacturing problem. So here in the case, we'll walk through an example for brake caliper mounting bracket issue. So where mounting bolts could not be assembled at the vehicle assembly line due to hole misalignment. So it will be having different reasons for that we'll look into that. So I will take you through how this problem should be handled end to end from issue capture to prevention using a structured digital approach. So here I'll be in this stage, what I'll be doing is I'll be issuing the tool called first. I have to recognize the issue first. So the assembly line reports difficulty in assembly brake caliper mounts bolts resulting in live stoppage and rework. So what you're seeing is a tool which is already available in LiveQC Tools, that is live issue module. There you can log in those issue details from here. So once you have put those details in the module over here, then since this is a repeated task on the safety critical components, the formal problem solving approach is triggered using the quick fix. So in the system, this captured as an issue, ensuring traceability from every beginning. So the next step is team formation. So once the issue is logged, the next step is to form the right team. So here we define a cross-functional team that we have already discussed, that it should contain a quality manufacturing person from quality manufacturing or CNC programming or maintenance and the production, whatever the area that we are having. And the important point is that it's not about hierarchy. It is about the process ownership and expertise. So the tool ensures that roles are clearly assigned. Here from this images, we can clearly see that which and all area that we have assigned different users. It can be from quality engineering side or from CNC programmer or production supervisor or supply quality, different number of people. So here roles are clearly assigned. Responsibilities are very visible and ownership is explicitly provided. Now this is one of the opposite side that we can say that is the other side of the coin, that is what is the bad practice that we will be seeing in the team formation. So here you can see that this is a common process that we'll be adopting if if you are going with the bad practice. So that is, here you can see that the team formed only with quality engineers. The most of the time people will be including quality people itself. They won't include any other people from any other department. So no production or maintenance involvement. So team members have no authority to change process or names added just for formality. So these are the bad practice that we can see in D1, or is team formation. Now we move to the problem description. So now we defining the problem correctly. So instead of vague statement like whole issues observed, we structure the problem using different methods. It can be in 5WH or 5I or different process. So what exactly is wrong? So what is exactly happening? So those kind of details can be easily observed from here, and which product, which line, which side, those kind of representation can be easily shown over here. So which prevents unnecessary investigation outside the scope. So here what you're seeing is the customized form, which is already available in 80 format. So here in D2, in this separate problem statement, you can assign different details with the different dependable data. You can add different images, which will be related to the specific activity. So from this, what we can take as a key message is a poorly defined problem guarantees a poor root cause. Then we can go to the next one, that is interim containment action. Okay, so before that, just see what are the bad practices when we are dealing with D2, the problem description. So these are the different representation that we can see in problem description, like instead of representing in detailed way, whole problem is in bracket, or assembly issues observed, not quantification, not time reference, no boundary definition. So these are the different representation for the bad practice in D2, that is problem description. D3, that is interim containment action. So before we analyze root causes, so we must protect the customer. So that's the first case. So that's, we must protect the customer. So at this stage, interim containment actions are very defined. So suspect lots are segregated, 100% inspection is introduced temporarily. So we know that assembly line is actually is in a controlled manner. Will be control those assembly line here. So system tracks what containment is applied, who owns it, and when it can be removed. So what you're seeing is an conformance, non-conformance of the specific product, and we'll be assigning those details to the tool live NC module. So it can be shared with the different users who will be responsible for this NC activity. So importantly, this containment is also temporary, which is not a solution. So from what is the key message from here? Containment stops the pain. It temporarily stops the pain, but it does not cure the disease. So what are the bad practices that we can see in interim containment action? So adding inspection permanently. So we are unwanted increasing the cost of precision. Then you can see that calling inspection a corrective action. No traceability of inspected parts. No exit criteria for the containment. So these are the different bad practice that we can see in the interim containment action. So this is I have already mentioned that this is the heart of AT. So here we conduct a process flow review. So here we can see that we'll be using different tools, multi-tool approach. Here we can use the process flow chart, fishbone diagram, or 5-way analysis, any format that you want. You can link it over through D4 format. So once you have set the process, it has some certain procedure to do that. So we'll be starting with the step 1, that is process flow chart. So what are the different good practice when we are preparing for some process flow charts? So we'll be properly defining what are the different steps which will be taken care of this specific activity. And we already know that the issue is coming at the CNC machining area. So we know what are the different areas or different type of procedures that we'll be doing for the CNC machining activity, and what are the interim actions can be taken out from that, what are the observation, what are the evidence that we can take it from this specific area. So this is not limited for CNC machining. It also we can take it for different steps which is already in the process flow. So but we have already analyzed it is happening at CNC machining. So we just found out which are the different areas that I can explore for the root cause analysis section. So once you have identified which is the targeted area, then we can go for the next one. So what are the different bad practice when we are going with the process flow review? So using outdated flow charts. So reviewing process in the meeting room only and not physically verifying the process, skipping sub-steps. So if you are skipping the sub-steps, you can always make sure that you can always expect there will be missing some critical points in the upcoming stages. So once you have properly validated this, then what we can go for is properly identifying the content. So the potential causes and identified through these different methods. It can be a 4 method or 6 method or 8 method, which contains a different, that is man, machine, material, measurement, mother nature, lot of. So those causes are not assumed, so they are validated with evidence. So once you have found some specific causes for this this end result, we have to properly correlate with some data. So that is the requirement for this root cause analysis. So finally, through validated 5 analysis, we identify the true root cause. So before that, I just want to showcase how we are properly segregating this XM method through different approaches. So starting with the first one, that is man. So how we are validating? So observe multiple shapes, review training records, compare different rec by the operator. So these are different record details that we can obtain for this specific in this XM method. The next one is, so from here itself, we can easily identify that man is not directly contributing the issue, this misalignment. And if you are checking with the machine, it is also, we can see what are the different validation approach. Measure the locating pin diameter, check the clamp pressure logs, or machine capability studies. These can be easily found from these studies, and we can easily say that fixture locating pin, which is somewhat related to our whole misalignment. So we can say that this is somewhat related to our issue. So in this next method, here you can say what are the different type of methods that we'll be using. So review work instructions, audit setup approval process, check recent look tool change records. So these are the different standards which will be having a direct or high chance of relation with the our end cause. So this is also will be addressing these issues over here. And the next one is the material. So what is the validation approach? Incoming inspection data, supplier CPK reports, or dimensional comparison of pre-machining. So this and all, we can say that it is not applicable to with our specific issue. So we can easily omit it. The next one is the measurement is also, we can say that it won't come into picture. So it's a validation approach. We can say that gauge calibration records or MSA study or measurement repeatable tests, it won't come into picture. And we can also eliminate that specifics of course. And mother nature. Usually it will call like environment. So in this validation approach, we'll be fetching the temperature log, visual inspection of the feature, cleaning frequency review. So these are all different validation criteria that can be taken for this exam activity. So once you have found this data, then root cause is not what sounds illogical, it's logical. So it's what is proven over here. So once we have found that, so the next step is 5Y. So this is basically for identify the true root cause for fixture locating pin wear combined with the absence of the preventive inspection. So the key message, what you can take it from here is root cause is not what sound logical. It's what is logical. Next one is the D5. So this, what we have seen is the good practice. And the next one is the permanent corrective actions for the D5. So once the root cause is confirmed, we define permanent corrective actions. So those are the actions not focused on the inspection training, but on changing the process itself. So fixture pins are replaced, preventive maintenance is updated, setup validation is enforced. So each action is linked to one responsible owner. So here itself, we can see that it is connected to the responsible owner itself. And we can also include the implementation, evidence of the implementation, those kind of these target dates and verification criteria. All these kind of data will be provided in the maintenance corrective actions area. So what key message can be taken from here? If the process doesn't change, the problem will return. So these are some of the bad practice that we can see in D5. So corrective actions, you can see that operator retrains only. That is the most repeated word that we'll be using in the AT form, operator retraining only. Additional inspection, be careful instructions. So these are the vague instructions or the representation in the bad practice of D5 or permanent corrective actions. Next one is D5. So for the verification of the effectiveness. So corrective action is not complete until it is proven. That we know that when it should be effective, it should be proven. So here effectiveness is verified using real product data. So whole element capability is measured, assembly defects are monitored over time, poor performance. So the poor performance characteristics. So the performance before and after implementation is also combined over here. So only after sustained results are confirmed is the action considered ineffective. So what key message what we can take it from here? So implementation without verification is assumption. So let's see what are the different verifications for the effectiveness that we can use. So what you're seeing is a symbol representation for the from one of the example from the SPC. There's nothing but control charts. So this is one of the previous data that we have taken for the this root cause analysis section. Then after the study, after the implementation, after the corrective actions, we got a improved CPCPK from the data that we are inputting through LSL and USL data. So from here itself, we are properly providing the real data, that is some evidence for the improvements in the process. So the next one is what we can do. So verification, then what are the different bad practice that we can see in D6? Closing immediately after implementation, or no data comparison, or defined or not defined verification period over here. So this is where the many organizations stop, but this is where real quality begins. So learning from these issues are now institutionalized. We know that PFME is updated with the actual failure modes. So here, this is the D7. Here you can see that implement preventive actions. Here will be defining which and all documents needs to be updated, whether it's applicable, who is the responsible person, who is what is the target date. So those kind of updation needs to be updated, because most of the time institutions are not updating based on their relevance. So here we'll be updating the PFME. The PFME updated with the actual failure modes, and the control plans are revised. So what it will do, its preventive checks are standardized across the lines. This ensures that same problem does not appear in a different form. So what key message what we can take it from the D7? So the prevention turns a solved problem into organizational learning. So these are some of the bad practice that you can see it over here. So no FME updates, or local fix only, or no knowledge sharing. So coming to the next one, how it will be closed. So team recognition and the closure. Finally, the team's effort is formally recognized and it is closed only after all actions are verified. So system updates are complete and the learnings are documented. Recognition reinforces the right behavior and strengthens the problem solving culture. So from this session, what we can take as key message is the 80 closure is not the end. It reinforced the discipline details of 80 structure. So what are the different, here we have already seen what is the good practice and the bad practice. So in the good practice, we can see always it will have one acknowledgement for cross-functional effort. And we'll be sharing the success story internally through mails or through some paperwork or some newsletters, something like that, and reinforce the problem solving culture. So what are the different bad practices that we are seeing in the D8? No closure communication, treating AD as punishment, and no appreciation. So these are the different good and bad practice that we can see from the D8 section. So what we learned today. So this case study shows how structured problems solving when supported by a digital system ensures discipline in execution, transparency across functions, traceability from issue to prevention, and sustained improvement. And this is how it moves being a report to becoming a system. So what we, as a wrap up, let's quick reflect on the key takeaways. First, it is not a document to be filled. It is a structured way of thinking, working as a team. Second, the problems are solved faster when we invest time upfront into defining them correctly and containing them effectively. Third, true root cause analysis requires data, logic, and discipline, not opinions. And finally, corrective actions without prevention only guarantees recurrence. So sustainable quality comes from closing the loop, and that's where digital execution plays a critical role. So I would like to close with one simple thought. So so it is not about closing your reports. So it's about closing gaps in your system. So when teams think deeply, act systematically, and learn collectively, quality stops being reactive and becomes proactive. So with the right mindset, the right methodology, and the right digital support, organization can solve problems once and prevent them forever. So Thank you for your time and engagement. And I would like to close with this one simple statement, that is, AT does not eliminate problems. So it eliminates the same problem that happens again. So before that, I just want to showcase different tools that is currently available. Like these tools, we can see that a lot of features are available, like data collection, process mapping, defect tracking, knowledge sharing, non-conformance, planning and task management, root cause analysis. AT is one of the tools that is available, like these tools, and preventive actions, records management, templates, SPC, measurement and testing like MSA, CP, FME, assets, audit, live configurator, issue manager. These are the different features which comes under single umbrella in Liquid tools. So I will be very happy to take questions from your side, and what is most challenging part of the AD in your organization today. And also you can scan this WhatsApp channel QR code and you will get the live video, that is recorded view of this session, and frequent updates from our side. And I'll be open to any queries, and you can share your thoughts or queries through the chat box.